This is Mario with MIA Microflight once again, and in this second video regarding this no sound, how to troubleshoot and fix a Yamaha PSR S910, I'm going to be I'm actually removing all these connectors. As I was mentioning in my first video, most of these connectors except for two have these disconnect connectors, except for these guys with the gray wires here. There's two of them here. One is for the power switch, which is, and they use 6 wires, to do a switch that takes 2 leads. I don't know why they did that. And this is the one. I believe this is the one that goes to the speakers from the amplifiers. This is the amplifier section. This is your power input section, power supply basically. 16. That's your regulator section right here. Regulator takes the input voltage, 16 volts, and converts it to 12 to distribute to the rest of the circuitry that requires 12 volts. You'll see in a minute what this board looks like underneath. I'm basically removing everything here. They also did this grounding lead here. This was a solid lead, so if you're going to work on this board, you almost have to cut this lead, or you almost have to cut this lead to access this board, to lift this board out, and you have to remove these by removing these clips, from these connectors. I don't know, like I said, why they didn't just put regular connectors so they can disconnect everything nice and easy, lift the board for servicing. But anyway, I am going to be taking these two connectors with these wires, these crappy wires here, and I'm going to be putting my own connectors. So I'm going to use pigtails because I can't use the connectors that I have direct on the PC board because of these are very narrow distance on the pin, from pin to pin, and the ones I have are a little bit wider. I could buy the same ones, but I just don't want to wait. So this is what the board looks underneath. And let's look at the there's the power. Let's look at from the power input side here. So you're coming in here. As you can see, there's a lot of little chips here. More chips. Most of these are probably op amps, and probably some signal processing chips, before they go to the amplifier chips, which are those. I believe that's an amplifier chip. I know that this is for sure. This is an amplifier chip because I looked that up. This one right here, I haven't cross-referenced that one, but I believe that's also an amplifier chip. Mainly the power supply is right here. It's this little transformer here with this diode. It goes through this. This is a ceramic fuse. So if you were to lay out this and trace all these lines, unless you have a schematic, it's very hard to get schematics. I mean, the service manuals do give you a picture of the board, from the bottom and the top, but they don't give you schematics on these things. So what I did is, in order to trace all these things, as I explained in my other video, is I had to make my own schematic just to see what's going to what, and so that I can test certain points, for voltage and for shorts. But basically, this board is working just fine. Let me go to my workstation here, or my test bench, and then we can see what I'm going to do here. Okay, so let me turn on my light here. It's going to get very bright here because my bench is very bright here. Okay, so this is the capacitor that I removed, the original one, 6800 microfarad. And if I put a meter with a capacitance readout, this is a meter with a capacitance readout, across, well, first you have to short the leads before you test this, and then put the leads across, the negative to the negative, positive to the positive. This reads, I can't do it right now because I'm working with one hand holding the camera, but this was reading about 600, not 6800, but 600, very, very low capacitance. And so I decided to replace that with the other one that I mentioned in my first part of the video, which is that 4700. That's what I had, but I'm going to buy that same value and replace it. This will work. as I just tested in my other video. You could hear sound again from the keyboard. Pretty much everything else looks pretty clean. I mean, I do like to keep my stuff clean and intact, and I do like to service once in a while my equipment so that it lasts a little bit longer. This keyboard is over 10 years old. I really like the sound. I don't think the new ones have anything spectacular as far as features, upgrades. The sounds are they tend to shift the sounds over to the new keyboards, and they charge you more money because apparently it's a new thing. I don't think it's worth it, and so I rather fix my keyboards, my equipment. And so this is the bottom. What I was saying, what it looks like. This plate that I'm going to show you here in a little bit. This plate is a metallic plate that is installed. I believe this goes like that. On top of this, no. This plate goes like this and attaches with a bolt right there. And so I marked this because I was also testing this op amp on the input of the microphone. This is the input section of the microphone. This whole section here. That I believe the second pin, or the third pin is the from the left is the 12-volt input required for this operational amplifier to work. So if you put a continuity test between pin number 8 and that pin right there, it should read as a short because pin number 8 is the VCC supply to this chip. Pin number 4, which is on this side, is the ground. If you put that continuity from that to ground, you're going to need to read a short because that is ground. So I was not getting 12 volts here at all before, and it had to do with this capacitor. By going direct 16-volt input, and I have a power supply here that I use. That's my power supply, and I did inject 16-volt here, and I also shorted these things to see if I can get the 12-volt working out of the regulator, and that's how I tested my regulator, which is that little chip right there. And so I was getting 12 volts after doing that when I replaced this capacitor. So this is why I'm saying that the culprit is this capacitor here. Now what I'm about to do in the circuit board is I am going to remove these connectors here. These are the connectors that take those gray wires. They take these wires right here. And I had to cut mine because I could not access this easy as these other connectors. You just lift them, they kind of clip a little bit, you just grab it, lift it, and they come out. These guys right here, you have to pry out the little cap that holds these pins in place, and it's kind of silly to have all these connectors here. You have all these connectors except for 2 of them that are almost hardwired to the board, as well as this ground cable here that's also hardwired to the rest of to the cable that goes somewhere to a ground there. So I added this quick disconnect here that I could disconnect the other side of the cable to this here. So I'm going to retain that one there, but I am going to hardwire to the PC board, and I'm going to put my own connectors, just pigtails that I can disconnect nice and easy. And I don't have to mess with these things because these things are pain in the butt to get it just aligned properly or just right. Stick it in there and then have to cap this, on top. It's too much work. So I'm about to do that, and in the next video you'll see my keyboard, this already on the keyboard, and we'll get the sound again. This is working. I hope I don't do some silly thing here on this board where it renders it unusable, which is possible if you're not careful with these chips. You got to be grounded. I do have a grounding strap on my table here that I wear, or sometimes I just ground myself to the metal cabinet here. before working on these chips, because some of these chips are susceptible to static electricity. Right now, at this time of the year where I live, there's no static. I don't walk through carpeting. There's no carpeting in my home, but it is possible to lift some static in your body where you can discharge on one of these chips, and that's it. You blow the MOSFETs, metal oxide field effect transistor materials that are susceptible to static electricity. For those of you who know electronics, you know what I'm talking about. So that's what I'm going to do, and I'm just showing you in this video so that if you have something similar, you can consider doing the same, because the way they connected these things is just, in my opinion, it's just poor design. You know, if you're going to provide disconnects, easy disconnects on most of the board, 99% of the board, only two connectors, you know, with these silly direct connections with these cables, you know, come on, Yamaha. And this is to Yamaha if they're watching this video. You know, just supply regular connectors so it's easier to disconnect. You could do the same thing I did here. Provide this with a connector that you can disconnect this ground cable. That I don't know why they did this with this separate ground cable that goes to somewhere to a lead. I didn't trace that lead, but this is connected to the ground side of this capacitor. So this is where I'm at, and when I'm done with that, you'll see the last part of this video, the third part. Stay tuned for more.